Alright, let's take a look at an example of how we can use simulation or FEA to help zero in on the best design to move forward with. In this example, we have a mounting bracket where we have two different concepts. One has a single web design, and then we have a double web design. We want to determine which one of these is the better choice for our needs. A simulation is about testing designs on the computer. So the first step is to pick the type of test we want to do. You can see we have a lot of choices. We're just going to focus on static strength. For this, it's just a matter of applying a load and holding the part in place as we would for the real experiment. In this case, we're going to apply the fixture. There are several ways we can go about doing this. We could hold our part just at the bolt holes, or as in this instance, that the back face is welded onto the wall. With the load, we can conveniently use geometry to specify the location as well as the direction. We're going to apply a 20 kilogram or 200 Newton load on the bracket. And that's really all there is to testing our part. We also have symbol displays to provide visual feedback on how our test is set up. We select Run, and it measures the part and then goes through the calculations. We can use the command manager to interact with the model if we choose, but the right-click menus are more convenient once you're familiar with the steps. So you can see with the double web design that we have a stress of just over 11 megapascals in the web. Well, what about the other concept? If we change to the single web concept, we can take advantage of the simulation study we just created and make a copy using the duplicate command for this configuration. We need only click on the Run to get the results. It will automatically mesh the model and get our result in a couple of seconds. We can see that for the same applied load we have a peak stress of only 8.5 megapascals, down from 11, so about a 20% reduction. So this would suggest the single web design would be a better option for this load condition. Now if we're more concerned about the stress near where we're mounting it onto the wall, we can refine our restraints. In this case, instead of assuming the entire face is welded, we'll assume that it's bolted to the wall and that the bolts are taking the entire load. Now this is going to be very conservative, but it's worth checking it out. And when we say conservative, that means that the stresses are going to be higher than reality. So instead of picking the back face for the fixture, we just select the bolt holes. And when we run the simulation now, we will see what the difference in stress is. So we were around 8.5 megapascals, and now the peak stresses are significantly higher and localized around the bolt holes. For the real bracket, the stress result is going to be somewhere between these two solutions. And we can actually account for this in SolidWorks simulation if desired by creating bolts. So it's easy to do some quick design comparisons in SolidWorks simulation and choose the best design to move forward with.